Welcome to Solving Radical Equations and Inequalities. I think with the base that you have leading up to this point, this is going to be no problem at all for you folks. Hopefully it'll be nice and quick and easy. So the whole idea behind solving radical equations is really just to isolate the radical. It's very similar to solving equations when you have a variable. You want to get the variable alone. Same deal with the radical. So isolate the radical, and then whatever it takes to get the power equal to the index of the radical so that you can basically solve for x. And then you'll simplify and solve from there. We're going to solve each equation. First step, again, is to isolate the radical. So in this case, the radical is the square root of x minus 1. So we take care of the rest of the bits. So we have the square root of x minus 1 equals 1. Now, this is a radical that we don't see an index, which means the index is 2. So we square both sides of this equation. We get x minus 1 equals 1 squared, which is 1. Then just add 1 to both sides, so we get x equals 2. When we check that back into the equation, we get 4 plus the square root of 2 minus 1, which is 1. And we want to know if it's equal to 5. 4 plus 1 is in fact 5, so that answer works. X equals 2. So we have another one, 1b. This time our radical has an index of 3, which means we need to cube this side of the equation. Because if you think of it, this is really 3x minus 4 raised to the 1/3 power. We'd want it really raised to the power of 1. So we cube both sides of the equation. We end up with 3x minus 4 equals 2 cubed, which is 8. Add 4 to both sides. 3x is equal to 12. Therefore, x equals 4. We can plug that in easy enough. 3 times 4 is 12. Minus 4 is 8. The cube root of 8 is 2. Our answer works. See, I told you it'd be nice and easy. No problem at all. So there are times we might have a radical on both sides of the equation. We have a situation like that. It's really no different. We are just going to square both sides of the equation again. You have to be careful of one thing, but nothing major. So when we square this side, we get 8x plus 6. Square the other side. 3 squared is 9, and then the square root of x squared is just x. So when we solve from here, we bring the 8x over to the other side of the equation. X is equal to 6. We can plug that in and see what we come up with. 8 times 6 is 48. 48 plus 6 is 54. So we have the square root of 54. And over here we have 3 times the square root of 6. Now we have to check this because we have 54, which is 9 times 6. The square root of 9 is 3. So we do get 3 radical 6 equals 3 radical 6. So that works. Now for 2b, same idea. We have an index of 3, which means we need to cube both sides of the equation. Remember, it has to be the entire side. So when we cube this side, we get x plus 6. When we cube this side, 2 cubed is 8. And when we cube the cube root of x minus 1, we end up with x minus 1. So we have x plus 6 equals 8x minus 8. We get 7x equals 14. Divide both sides by 7, so x equals 2. So make sure, hopefully you noticed this bit right here. This is 8 times the quantity x minus 1. So it's not just 8x minus 1, it's actually 8x minus 8. So when we check that 2, on the left-hand side of the equation, we get the cube root of 8. On the right-hand side of the equation, we get 2 times the cube root of 1, which is 1. So again, this answer works. So I think from here, I'm just going to do one of each of these problems, and I'll just tell you what the answer is for the other problem. So we work on here, you'll notice that I put that you may get extraneous solutions. You definitely want to check the ones where you have a radical on one side and a variable on the other, because you're really going to, most of the time, introduce or many times I should say, introduce an extraneous solution. So in a problem like this, we square both sides. Here we get 2x plus 14. Now, you know this one is a brass ruler mistake, so don't mess up on this side where you have x plus 3 all squared. Because when we square that, we get x squared plus 6x plus 9. Anything other than that, you're in trouble. So if we bring everything over to one side of the equation, we get x squared plus 4x minus 5 equals 0. So we can factor this, factors nicely, x and x, 5 and a 1, and a plus and a minus. Therefore, we get x equals negative 5, or x equals 1. So we have to test this, and I'll tell you what, this negative 5, when you put it in on the right-hand side, because you have to go back to the original equation, when you put it in on the right-hand side, you get negative 2. There's no value that you're going to be able to put in on the left-hand side to come up with a negative. So that negative 5 is out. So now if we test the x equals 1, on the left-hand side, we get 2 plus 14, so we get the square root of 16, which is 4. And then on the right-hand side, we get 1 plus 3, which is 4. So again, we had ended up with an extraneous solution. It's an extra. So we get that x equals 1, and that all works out. For 3b, I'll tell you the answers are negative 4 and 3. So if you want to work through that, you can. Make sure that you get the idea. Now, there's really nothing different about these two examples, other than the fact that we wrote them in exponential form instead of in radical form. But other than that, treat it the same way. So I don't know if you have a preference of one over the other, but why don't I do 4b this time, since we have an extra step involved. Remember, you have to isolate the radical, which really that x plus 6 is the radical. So we'd want to first divide both sides of this equation by 3. So we get x plus 6 raised to the 1/2 equals 3. So we have something raised to the 1/2. To get rid of that, we square it. Whatever you do to one side, you have to do to the other. So we get x plus 6 equals 9. Subtract 6 from both sides, so x equals 3. And then we'll check it back in the original equation. So we get 3 times 9 to the 1/2, and we want to know if it equals 9. The square root of 9 is in fact 3, so we get 9 equals 9, so it checks. In case you are wondering, on the first one, the answer to that would be 22. And you can almost see that one, because 22 plus 5 is 27, cube root of 27 is 3. But you can certainly work through that one as well. And the inequalities, again, really nothing terribly different, except you do have to check for one little thing as you're coming up with the answer. So in this particular one, we still want to isolate the variable. And when we look at this, we have the square root of x minus 3 plus 2 is less than or equal to 5. So subtract 2 from both sides, so we get the square root of x minus 3 is less than or equal to 3. Take the square both sides, so we can get rid of that radical. We get x minus 3 is less than or equal to 9. When we're at this point, we have x minus 3 is less than or equal to 9. Add 3 to both sides. That means that x has to be less than or equal to 12. And we also know that x minus 3 has to be greater than 0, because if it's less than 0, we end up with a negative under the radical, which gives us a non-real answer. So x has to be greater than 3. So x or it could be greater than or equal to, sorry, greater than or equal to 0, because it could be 0. So x has to be greater than or equal to 3 and also less than or equal to 12. So x is greater than or equal to 3 and less than or equal to 12. And for the second one, we end up only with one bit where we just have that x is greater than or equal to 1. -1, sorry, over here, if you want to run through that as well. You'll notice that when you do that, you end up with the two cases, but that's the one that makes it true for both. Oh, that's it for today. Hope you enjoy your Blizzard Bag Day.